Let n greater than equals to 1 and A is any matrix of this size n cross n satisfying a raised to the power k equals to 0. This is true for some k which is also greater than equals to 1. I be the identity matrix of this size n cross n matrix. Then we have four options. I plus a need not be invertible. Determinant of I plus a can be any non-zero real number. Determinant of I plus a equals to 1 and a raised to the power n is a non-zero matrix. As a raised to the power k equals to 0, this is true for k greater than equals to 0. It means matrix A is a nilpotent matrix, and we know that eigenvalues of nilpotent matrix all are zeros. Means eigenvalue of A is 0, 0, 0 n times, and eigenvalue of identity matrix is 1, 1, 1. All are same. Then eigenvalue of their sum means a plus I will be 1, 1, 1, and so on, and product of these will be the determinant of matrix A plus I, and that one will be 1. That one will be 1. So option C is correct, and I plus A is invertible, but option A is saying not be invertible. That's why wrong. Determinant of I plus A can be any real number, but we observe that determinant is only 1. So this is again wrong. As A is an nilpotent matrix of this size n cross n, that's why A raised to the power n equals to 0, but statement D is saying A raised to the power n is a non-zero matrix. So correct key for this problem is option C.